next topic is permutation. Permutations and permutations and combinations. Okay, now before looking at the actual concept of what is called as the permutation and combination, we need to look at what is called as the fundamental principle behind counting. So this whole concept is about counting, right? In how many ways you can do something, or in right, what are the various combinations you can perform, right? So that's why the name is permutation and combination. So before looking into the details of this, we need to consider, right, two fundamental principles. So the first principle of counting is called as the multiplication. It's a multiplication principle. Right. Now, let us say there is what is called as there is an operation which can be performed in m different ways. And let's say there is another operation that can be performed in n different ways. One is m, one is n. Right. Then the two operations in succession can be performed in m into n ways. That's the fundamental principle of multiplication in mathematics. Right. So let me give a statement here. That is, say, if an operation can be performed in m different m different ways, comma, following which there is a second operation that can be performed in, say, small letter n different ways. First one is m different ways, and second one is n different ways. N different ways. Then the two operations can be performed in succession in how many ways? It is m into n different ways. So this can be considered as right, multiplication, and the operation is n, m and n. All right, so m into n, we try to, it's a m and n. And is multiplication. Okay, now let's go for an example for this kind of problems. Right, this is, I don't have to apply any permutation combination to solve these kind of problems, simply based on the multiplication principle. Okay, so this is an example problem. Say we have a hall. Let's say it actually has 12 different gates. Right, a hall has 12 gates. Question is in okay, in how many ways can can a man enter the hall enter the hall through one gate and come out through different gate. So there are 12 gates, right? One can enter through one gate, but he has to come from the different gate. So you see, entering can be performed. So you want to look at the answer. Entering m ways, that is 12. When you enter from one gate, you have to come from the other gate. How many other gates are there? 11. So this is the answer, right? That is 12 into 11. Totally 132 ways this can be performed. Very straightforward principle of multiplication. All right, then let's go to the next principle of fundamental principle of mathematics. This is called as the principle of addition. Right, now once again, let us say there are two operations. First operation can be performed in m different ways, right? And there is another operation which is independent. It is not at all related to the first one, and that can be performed in n different ways. Okay, then either of the two operations can be performed in m plus n ways. So the previous one is slightly different compared to this one. The multiplication principle is slightly different. Okay, let's write the statement, then we'll look at the details. Okay, right. So the addition principle is as follows. So if an operation can be performed in, this is m different ways, and another operation which is independent, of the first operation can be performed in n different can be performed in, say, n different ways, right? Then either of the two operations can be performed in, right, totally m plus n ways. So previous one was multiplication, now it is addition, because this is or, right? Either of the operation, in the sense first one or the second one can be performed in this kind of m plus n ways, right? So we have to take a note here. So previous one was and, right? Both m and n can be performed in m into n ways. So this is, if it is and, right, what I have to perform, I have to multiply. So if it is or, either m or the n, that's why m plus n, this is, right, addition. Okay, now let's go for an example here. A class has 10 boys and 15 girls. Okay, now the class teacher selects either a boy or a girl as class representative, right? So in how many ways? This can be done. So you see that there are 10 boys, so one of them can be selected as class representative, which means it can be done in 10 ways. Okay, so I'm writing the answer. So for boys, it can be done in 10 ways, or a girl, right? So that can be done in 15 ways. So the answer is 25 ways. M is independent. Selecting a boy is independent of selecting girl. Selecting girl is also independent of selecting a point. So they are independent events. So you can do this in n plus n ways. So this kind of application, right? This kind of solving the problem is using a principle called addition principle from mathematics, which is a fundamental principle in maths. All right, let's move further. Now we'll bring in a standard notation in mathematics. This is called as the factorial. Factorial notation. Let's get familiar with the notation first, then we'll go for the further problems based on this. Okay, now, right, let n be a positive integer. Okay, then the continued product of first n natural numbers. If you now remember, the natural numbers are starting from 1, right? Not 0. 1 till any number, that is called as a natural number. So first n numbers you have to consider and take a product. So that is what is called as, right? First n numbers is called as the factorial. Factorial of n. Okay, so notation. Factorial n is n, you can write the symbol. All right, so this is called as n factorial. So when I write n factorial, this is the meaning is that n into n minus 1 into the number before that, n minus 2, into it's a product up to all the way till 1. So product of first n natural number is n factorial. Okay, so for example, you can write a 4 factorial, which is 4 into 3 into 2 into 1. That is 24. Like that, you can write 10 factorial, 15 factorial, and so on. Okay, so it's a simple representation. When I write n factorial, it means it is all the way, all the sum of all the numbers starting from n, right? N less than 1, n minus 2, and so on till 1. Okay. So we next look at the properties of factorial. So the first property is like this. If I have n factorial, I can actually write this is n into n minus 1 factorial. That is also equal to n into n minus 1 into n minus 2 factorial. See, the factorial is applicable only for this, right? So I can actually write in the same way, right? I can extend this as and when required. So that's the first problem. And the next property is about what if I try to write a factorial of 0. So 0 factorial is actually equal to 1 factorial also. That is also equal to 1. Okay, so 0 factorial as well as the 1 factorial, they are same and the answer is equal to 1. Okay, then okay, then we go to the next factorial, that is, if at all you have, this is first one, second one, and the third one. If at all I have to find out the 2n, its factorial. So this can be simply written as 2 to the power n, multiply this with n factorial, okay, into, I have to multiply 1 into 3 into 5 into dot 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 up to 2n minus 1. So 2n factorial can be written in this fashion. All right. Then fourth property, if I have to perform any n factorial divided by any r factorial, this means it is simply n into n minus 1, okay, into n minus 2 into all the way till the r plus 1, because r onwards every term will get cancelled from the numerator. So this is simply into r plus 1. Okay, so that's the next property. Then the fifth one is, let's say, n factorial divided by n minus r factorial. If you want to calculate this, then this will be n into n minus 1 into n minus 2 into all the way till n minus r plus 1. Okay, then we have another property, that is property number 6. If at all we find that 1 divided by n factorial plus 1 divided by n plus 1 factorial becoming equal to lambda divided by n plus 2 factorial. If at all some equation like this is given in a problem, this implies the lambda can be directly written. Lambda should be equal to whatever n you have, add 2 to that and raise it to the power 2. Then lambda is equal to n plus 2 whole square. All right, then one more. So if somebody says that there is a x factorial that is equal to y factorial, right? We have only following options. This implies either x is equal to y, right? Or, right? If that is not true, then you see x is 0, y is equal to 1, because 0 factorial and 1 factorial are same. Or the other option is only this, x is 1, y equal to 0. Only three options you have. You don't have any other factorials which they can call them as equal. All right. Okay, so these are the fundamental properties. Later on, we'll see the different properties as well. Okay, now let us try to solve some very, very simple problems based on this. Okay, so if n plus 2 factorial is equal to 60 times n minus 1 factorial, find the value of n. So we'll substitute and we'll simplify it now. So see, this is n plus 2 factorial, right? So the given equation can actually be simplified as n plus 2 factorial divided by n minus 1 factorial. I'll bring it to the denominator. Okay, n minus 1 factorial is equal to 60. Okay, now either you use the property that is n factorial divided by r factorial, right, which is n minus 1, n minus 2 up to, right, r plus 1. Okay, so what I have to write now, instead of n I have n plus 2, right? I have to write this right? I can write maybe the numerator as m. See, m is equal to, I'll write m is equal to n plus 2, and say r is equal to n minus 1. So I know that m factorial divided by r factorial is nothing but, according to rule, you start from m into m minus 1 into so on. What is the last term? M. It should be r plus 1. Correct? So that's what is the rule saying. Right? It should be simply until r plus 1. Whatever is the denominator plus 1. Okay, so now let us try to substitute the values over here. Therefore, in the given problem, our solution is like this. This implies, so therefore, m is nothing but n plus 2. I just have to find what is r plus 1. So r plus 1 is equal to, this is n minus 1, right? N minus 1 is r plus 1. So this is still r, right? Till n I should write. So starting from n plus 2 into n plus 1 into n. That's what is the simplification of this term, right? This should be now equal to how much? That should be equal to 60. Okay, so this is equal to 60, right? Simply, right, solve this equation and find the value of n. So you have multiple option, n into n plus 1 into n plus 2 should be equal to 60, so that you have to find the value of n now. So this equation, if you solve, you get n equals to 3. That's the answer. All right, let's proceed further. The next topic is called as the exponent of any prime number, that is prime denoted by p, in any n factorial. Let's try to define what we are trying to identify, right? This exponent of a prime number p in any n factorial is denoted by the EP of n factorial, where p is a prime number and n is a natural number. Okay, so here the condition is that p is a prime number and n has to be any natural. It is any natural number. All right, now this actually represents the last integer among 1, 2, 3, 4 up to n minus 1, right? Because n factorial is n into n minus 1 into n minus 2 and so on up to 1, right? In that, right, what we are trying to find is that which is the last integer, right, among, so I'll write, so the last integer among 1, 2, 3 up to n minus 1 comma n, right, up to all these numbers, right, among all these numbers, which out of so many integers starting from 1 till n, which is the one 1 till n, which is divisible by p, right? Is I have to perform n by p, right? I should multiply that by p. Okay, so here the this operation, right, that is whatever is inside the bracket is greatest integer. This represents the greatest or the biggest integer, right? So n can be say 10 and p can be 3, right? So 10 by 3, answer is 3.33. So which is the biggest integer out of that? It is 3. So that is what is meant by this. Okay, so I want to perform this implies, let's try to give a mathematical representation for this. If at all I want to find EP, right, of the n factorial, this is nothing but I have to find out the prime factor, that is EP, of all the numbers starting from 1 comma 2 comma 3 dot 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 up to n minus 1 and n. This is what I want to check. So what I mean is that all the multiples of p needs to be considered, correct? So this is the largest uh, prime factor of prime factor is p, 2p, 3p. What is the last number? That's what I want to find. So you may have the n minus 1 times p, and the last number will be n by p into p, right? So the remaining natural numbers from 1 to n may not be divisible by p. Okay, so what we try to do now, so this can actually be represented as, right, this is equal to, right, the n by p, right, they are, that's the number, plus the ep of 1, 2, right, up to n by p. In this, whichever is a number, I need to find out. Now let's say that this is repeated, right? So anyway, there is a calculation that we can perform, and I'll write the final answer, right? So like this, we have to do for every number. So the final answer, if at all we want to find EP of n factorial, that is nothing but simply you will perform n by p plus the n by p square plus n by p cube, right? Every time you calculate the largest one. Okay, up to this has to be repeated till where this is n by p to the s, right? Right, where s is, the s is the largest natural number, it's largest in such a way that p to the s is less than or equal to the number which you are trying to find out, that is less than or equal to p to the s plus 1. Okay, all right, now let's this is a problem. Now we'll understand the application. Okay, so this is the question based on this part. Find the exponent of 3 in 100 factorial. So the question is find b is equal to e3 of 100 factorial. So you see what is the factor of 3, right? How many times 3 into 3 into 3 into 3 will come when you try to simplify 100 factorial? Is a question, right? As just you can see that this is the answer. So EP of n factorial has is nothing but, look at the n is 100 divided by the number is, first number is 3. I have to take the largest integer in this result. Only integer part you need to take. Next, 100 divided by, this is 3 square, right? Plus 100 divided by 3 cube, right? Plus, right? Like that you have to write the terms until, right? This condition is satisfied. What is P? P is equal to 3. So 3 to the power what number, right, is satisfying this condition. So 3 to the 3 means 27. 3 to the 4 is 81, which is less than 100. So I'll apply a condition. So 3 to the power 4 is less than or equal to 100, which is less than or equal to 3 to the 5. So you see that I have to do this till s is equal to 4, right? So this is 100 divided by 3 to the 4. Take only the integer values. Okay, so that means first number gives you 33, because 33 point something, so the answer is just 33. Plus next number, 100 by 3 square, 3 square is 9, 9 into 11 is 99 point, so there is point remaining, you can leave that. Then you see 3 cube, right? That is 27. 27 can be multiplied by 3 times, still it is less than 100. And 3 to the 4 is 81. 81, right, goes one time. So this is the answer. You can see that it is 33 plus 11 plus 3 plus 1, so 48 is the required answer. So 3 to the power 48 comes in, right, the 100. Okay, next. We'll ask a similar question. Find the exponent of find the exponent of 2 in 33 factorial. Yes, right. So the answer is 31. Okay. Right. Then we have another concept that is related to this. This is a note. Okay, we use this note to solve some other type of questions. So here, right, this is to find the numbers of zeros at the end of n factorial, right? If at all I want to find the number of zeros at the end of that n factorial, you simply have to calculate E5 of n factorial. Okay, this is a note. This is asked many times. Find the number of zeros in any factorial equation. Very simple to find. Okay, so example, this is the question. Find the number of zeros at end of 100 factorial. Very simple answer. I just have to find the E5 of 100 factorial. Okay, so this comes to be 24. So very easy method to find out how many zeros are there at the end when you calculate any factorial.